Lesson 5-6. Proving something is a parallelogram. So we'll draw a little figure of what a parallelogram looks like. And we have 5 basic strategies, which I'm going to highlight to you here shortly. When we get to 5-7, we're going to prove the shapes are something other than a parallelogram. But we want to start off with this kind of basic high order, right? Remember, the parallelogram is on the top end of the food chain. It is the most general, along with the kite, yes, object in that chain. Everything else kind of feeds off of that. So, coming back here. Idea number 1. I'm going to highlight the noun and the verb. So the noun is pairs of opposite sides, right? Both pairs. And then we'll say they are parallel. That's the definition. Okay, if you have opposite sides, bam, parallel. If you have both pairs of opposite sides, to be congruent, then again, you would have that. And the way I would write these out, shorthand notation, is I would say pairs of opposite sides parallel. Then you have a parallelogram. And then, same thing, only with congruence for the other one. Line 3. If one pair, okay, not both pair, just one pair, is both parallel and congruent, okay, so both qualities in that single pair, then that would be sufficient. If the diagonals of a quadrilateral bisect each other, then that would be sufficient. If both pairs of opposite angles are congruent, then that would be sufficient. So as we look at something like this, notice the directions in the proof say, show this is a parallelogram. So I have to pick one of these 5 strategies. Okay, what am I going to go for? Am I going to go for opposite sides are parallel, right? Well, in this case, not that one, but I want to look at the inner one, right? Because I'm trying to show this is a parallelogram. Or I could say, oh, okay, no, I'm going to show that opposite sides are congruent. I'm going to show that one pair of opposite sides is both parallel and congruent. Or I could go with, again, opposite angles are congruent. Or I could look at the bisectors. Now, I think right now as I look at that problem, I'm probably leaning on one of the front 3. And I'm going to list out this information, and I think that's going to narrow it down to 2 choices. So we know that we have a parallelogram, so I already know that this side is parallel to this side, and this side is parallel to that side. That's kind of nice because already I know that this side is shared, right? So that side is parallel to the other side. I also know that this angle is congruent to that angle, which tells me I could probably mess around with these 2 triangles, and then I could probably get some CPCTC. I could get this part, right? Congruent to that part. Well, do I want to show then this part congruent to that part? I'm liking that strategy because I think I could show this and this are congruent, and therefore I could subtract out, right, and leaving me those 2 pieces. So I'm looking at opposite sides are congruent. So number 2. All right, here we go. So again, the first strategy, show those 2 triangles on the outer edge are congruent. And I think what we want to do is I've got opposite angles. That's a property. And then I've got opposite sides. Okay, so AF. is congruent to CD. And that's a property of property of parallelograms. Since we have a parallelogram, right? Number 3. We're given the one angle, and now we need to say angle A is congruent to angle D. And that is because, again, another property of parallelograms. Line 4. I think I have my 2 triangles congruent now. Triangle AFB is congruent to triangle AFDCE. And I think this is the ASA postulate. Number 5, because of that, now we pick up some parts, right? We know that FB is congruent to EC. It would be nice to go with the angles and try to show alternate angles and then go parallelity, but I don't see a common transversal in this case. I think you could, right? I think you could show this angle here is congruent to this angle here. No, you can't, because we don't know that those lines are parallel. So scratch that idea. Keep going. I think we're there. CPCTC. And now I want to get the opposite sides are also congruent, so FE and BC, right? I want to show that this is congruent to that. All right, again, we know that AC is congruent to FD. And that's another property. Of parallelograms. Line 7. If those two are congruent, then we know that by subtraction, FE. Have we already said AB? Nope, I guess we got to state AB first of all. AB is congruent to ED. Again, that is by CPCTC. Now, by subtraction of pieces, we can claim BC is congruent to FE. Subtraction of segments. And that takes us to line 9, which is that FECB is a parallelogram. And why is that? Because we have opposite sides are congruent. Okay. Finally, there are problems that show up in the section. So here we want to show that something, again, is a parallelogram. So clearly they're talking about angles. Now the things that we know about angles in a parallelogram is that they're supplementary. If you look at those ones, right? Consecutive ones are supplementary. And then the other thing that we know is that opposite angles are congruent. Of those two ideas, I like this one here better, because obviously equality is easier to show than supplementary, because you don't have to mess around with 180 degrees. So let's try that. I think either strategy will work. I just think this will be faster. So 3x times x squared minus 5x should equal 3x cubed minus 15x squared. And notice when we distribute here, we get 3x cubed minus 15x squared, right? So yes, that worked out nice. By the same token, I think if we take x squared to the 5th power, that is going to give me x to the 10th, because Remember, we take those powers of powers, we multiply them. Don't know if you covered that in last year in algebra class. But a power of a power you multiply. Okay? Whereas over here, when we take this power, x to the first, x squared, we get x cubed. We add those powers. Right? X to the first times x to the first gives me x to the second. So reviewing some ideas there, which might not be reviewing for you, it might be new powers of powers. All right, there we go. That is proven. We have opposite angles being congruent, therefore quadrilateral.